We have done the encoding of a plain text using the Vigenere cipher in the last video. What we're going to be doing today is we are going to do the reverse. We are going to have a cipher text and we're given the key and we have to implement the decryption algorithm using the Vigenere cipher algorithm. Right, so we have the cipher text here. This is actually from the last encryption exercise. It's the quick brown fox jumps over the lazy dog, encrypted using the key lemon, and now we have to try to decrypt it. Okay, so just like for encryption, the convention we are using is if we encounter any non-ASCII characters, we are gonna jump over it, pretend it never existed, and because of that, we will need to keep track of what's the next character that we're encrypting, what position it is in, because the Vigenere cipher is very much dependent on like how many characters have been encrypted or decrypted before this current character. We still need to use the for loop syntax to go through every single character, but this time around we are going to iterate through all the cipher, all the characters in the cipher string. We will need to check that our character is an ASCII character. So you'll notice that the framework for building our code for the past few ciphers, including this one, is very similar, right? We are generally doing the same thing. We have to go through every single character. We have to ensure they're part of the ASCII family, ASCII lowercase family. So because we are familiar with it already, it helps us move faster in terms of writing the code. We know that we kind of need those elements in place. We kind of have implemented it before, and so we're going to use that same pattern, that same algorithm, that same approach in here. Right, so here's the basic empty framework for us to do this. Specifically with the Vigenere cipher, we'll need to maintain the index variable. So every time we have done an encryption on a character, we'll need to move the index up by 1. And that is, of course, we'll need to make sure that it is limited by the length of the key. Once it goes beyond the end of the key, we want to wrap it around to the beginning, and we use the remainder operator or the modulo operator here, the percentage sign, to do that. Right, so we have sort of here, what do we want to do next? Right, so we need to retrieve the offset key at the index, okay, or rather the offset value. And so that comes from retrieving the key at the index. What's the letter that is going to be used for this, for decrypting this character? We'll find the numerical value from the ASCII table. We'll minus off the base offset from the A character. So, then we start off from 0. And this is sort of like the offset value. And so when we did the encryption, we added this offset value. When we do the decryption, we are supposed to minus this offset value, right? But just on this gut feeling that I have, I feel like I do not want to subtract. I want to keep going forward, and that is just somehow more comfortable to me. And so I know that using this modular arithmetic that is involved in this algorithm, we know that going back by 5 steps is the same thing as going forward by 26 minus 5 steps, right? Because there's this wraparound that goes, this circular arithmetic that goes around, right? Um, so our positive offset, I'll call it, will be 26 minus our offset, right? So we don't want to minus, we want to add at the same, yeah, right? We want to add rather than minus, okay? So now we can retrieve our character, we'll add the positive offset to it, okay? Right? Um, and and I guess what that means is that we'll never get a negative number, so I don't have to worry about how to deal with a negative number. I only have to deal with it possibly going beyond 26, and so we'll use the same thing, which is I will make sure that I wrap around by 26 if necessary. Okay, and I can't use C, of course I have to use the ordinal value of C minus the A offset. Okay, and so that's going to give me a number between 0 and 25. I'm going to print it out actually, just to make sure that we are getting a sane output from this rather complicated equation here. Okay, so we're getting a number between 0 and 25. That is good. And so we can then print it, convert it back to an ASCII character in the car function. And we want to make sure that we add our A character offset again when we do this. And this will be the decrypted C. Okay, by running it here to the CHR function, and so we can then add this now into our plain text. I think I'm missing a closing bracket here. We'll see. So plain text to plain text plus decrypted C. Let's run it. There might be a bug here. Let's see. Yes, an invalid syntax. What is? Yeah, I don't have a bracket, closing bracket here. My closing bracket should be at the end. Okay, right, this should be it. Okay, so there's no syntax error. So let me print out the cipher and the plain text that we have computed, and we really hope that it gives us the original phrase back. Let's run the module. Fantastic. Yes, we get the quick brown fox jumps over the lazy dog from our ciphertext. And so it gives us a very good confidence that our encryption and decryption algorithm is right. And we want to probably test it on a few other things, a few other phrases, and we want to maybe, like, let's say, hey, what if my key was wrong? Instead of lemon, maybe I use lemonade as my key, and that should make it not work. You can see that yep, it did not come back to the plain text. So we really need the right key for it to work. And so yeah, we'll do a bit more testing to make sure this is right. Before I end the video, I'm actually going to try to implement the algorithm without using this positive offset thing. So let's try it out. What will it look like if I didn't convert the negative of the offset to the positive of 26 minus the offset? So what happens is that I'm going to take my character, okay, and I'm going to actually subtract the offset. Okay, when that happens, what happen? We will. There might be a possible now. We don't have to worry about it going beyond 25, but we have to worry about it being negative, right? And so I will have to then keep track of this uh, in a variable decrypted C numerical value. And what happens is I have to do a quick check. If it is less than 0, then I have to add 26 to it. Okay, and so then and I'll put that in here, right? So let's run it, make sure it's working. Yep, it still works. We still get the plain text out. Um, I guess I don't like that I had to add another conditional statement here. The first solution that I did using the positive offset just seems a little bit more elegant. But maybe if I think about it a bit more, I could maybe change this program to be a bit more elegant too. But I can't think of anything at the moment. So that's where we're gonna stop. If you can find, if you can find a better, more elegant solution, I mean, please do share.